Hi, and welcome to Trapeze Lifecycle Approach to Asset Management webinar. My name is Michael Scully. I'm the EAM Industry Solutions Director, and I'll be your host for today's webinar. Firstly, I want to thank you all for joining us today. And before we get started, I just want to run through some housekeeping notes. The screen you're looking at can be completely customized. You can resize and move any of the windows you have open. We also have a bunch of buttons at the bottom of your screen, and I'll quickly go through them from left to right. The question mark is a help button. If you've got any issues, such as you can't hear any sound, please press that button and we'll have someone attend and provide you with immediate assistance. There's also a slide button to open and close a slide window, and I recommend keeping this window open. A media player in red allows you to control the volume. A Q&A button. We're definitely going to have a Q&A session at the end of the presentation, but do submit any questions throughout. A resource button, which includes complimentary content as part of today's presentation. And lastly, a contact Eva or Trapeze button if you wish to get in touch with us after the webinar. So look, that's it for me for now, that is, and I'd like to introduce Eva Diaz. He's the Director of Asset Management at Keolis Commuter Services Boston, and I've known Eva for quite a while now. We met back at Trapeze Think Transit in 2018, where we spent an intensive few days together attending various EAM sessions. And then we met again at Hong Kong Asia Pacific Rail in 2019, where we co-presented an ALIM presentation as well. So that's it for me. Eva, thanks for being here today, and I'm going to throw over to yourself.
All right. Thank you, Michael, for that warm introduction. As he mentioned, my name is Eva Diaz. I'm the IT Director of Asset Management here in Boston, Massachusetts, working on the Class 1 commuter railroad for the MBTA. Today's topic is the lifecycle asset management approach that we've undertaken here in Boston, and that we're working towards fulfilling all of our requirements for. So let's, like Michael mentioned, we'll have a little Q&A at the end, and feel free to shoot us any questions that you may have. But for now, I think we can dive right in. All right, so a bit of the agenda in terms of what I intend to cover. We'll get into the asset management fundamentals. We'll then dive into the asset lifecycle information fundamentals, the ALIM component of this presentation. I'll talk a little bit about why it matters, and I think that's one of the more key themes to convey in this webinar. I'll talk a little bit about the concept of integration in terms of how we're actually doing it, what does it look like behind the scenes, and then what good looks like at the end, which is something I always like to cover and spend a few minutes on. So if we dive right in, we'll start talking about sort of the asset management core framework. And to a lot of you, this is probably nothing new. This is the core framework of asset management, which entails, gets us to proper asset management. It's all about having the right maintenance done at the right time. That's the goal, and that's what we're all trying to work to. This is the, what is the product, what is the output, how do we get there? So typically, these systems will have, your the whole holistic approach of asset lifecycle, which incorporates your configuration and change management. We build on that with asset condition and performance management that informs our reliability measures. On top of that, we would have our asset lifecycle cost management, which is our predictive and prescriptive metrics associated that give us our asset investment planning and prioritization strategy, all building up to the asset management core principle itself of the asset definitions, the asset registry, and the classification of the assets as compared to its peers. With respect to the evolution of the asset information, most of you will recognize the different phases here of any project outlined across the top. You have your project planning phase, your design phase, your construction phase, operation and maintenance phase, and then your decommissioning phase. That is the full life cycle of any asset, regardless of how small or large it is. Now, what do we do with all this information? How do we manage revision and version control? Why does it matter? Who owns the golden image of the data? Why do we care about a single version of the truth? Those are all very good questions with rather complex answers. It's all about having the right information available to everyone in the asset maintenance world. And we must not ignore the fact that details matter. It is not enough to just fix something and get it out the door. That only perpetuates the legacy break-fix mentality. And that's where tools like Trapeze EAM come in and help you do that, because Trapeze EAM is tailor-made for rail. So, not much to cover here other than to recognize that, within each phase of the asset information lifecycle, you're going to have different types of data being available to you, which lead you to be able to have the operations and maintenance-related data that inform reliability and performance numbers, your maintenance standards, your material management policies, your corrective and preventive maintenance, your predictive maintenance, and all your associated KPIs that come along with having that information. If you can get to that point, then you're truly doing something right, because you have all your information in one system of truth. So now moving on here to the core of your typical enterprise asset management system. You would have an asset main information page, your asset primary in this case, in Trapeze, where you would have all your back-end information regarding the setup, what type of inspections, the frequency, the replacement strategy, warranty information. You'd have a picture of the asset if you have that. You'd have all your geospatial information that tells you where that asset is in space, and also any parent-child relationships that you've built into the system, which we get into on this next slide. Now, parent-child relationships are not uncommon, but they're very often overlooked in terms of how critical they really are in terms of managing the asset holistically throughout its whole life cycle. A good example would be a rail car that needs to have the traction motors replaced on an 8-year cycle. But because you've been doing such good maintenance, now that 8-year cycle can be pushed out to 12 years. So if the overall life cycle of that asset is 30 years, you've just saved quite a bit in expenditure, because you've proven that you can that because of your strategic maintenance plan, that component can last more than what was originally expected. So that's really the challenge, and that's really the value that we get out of core systems like these, where we're trying to manage the small things, because all the small things dictate how well the big things perform and evolve on your property. Now, you may have some baseline information that's been provided by your OEMs, but as we all know, that's in a static state under nominal conditions. We live in a world where it's we don't control the path that the equipment always takes. So one equipment's life cycle might actually be shortened just by the operating environment that it happens to be installed on. So having this baseline information is critical to being able to provide the most effective asset lifecycle plan. All right, so moving along here, getting into a little bit of the cost information. So why is that important? Well, as we all know, finance only cares about the numbers and the cost. So we have to be ready to provide that information back to them so that the right asset replacement, prioritization, rehabilitation strategies are implemented, and then our numbers match up. So having those parent-child relationships not only applies at the component level, it also really applies at the fleet level. So for example, you would have a rail car type A made by, let's say, Kawasaki, and you have 500 units. How well does each unit perform, and how much does one unit or a couple of units that perhaps were built towards the end of the production chain actually impact the reliability of that fleet? So having that all the information at your disposal is key and critical to being able to slice and dice the information and derive actionable data from that information. which is really the key for everyone. Having that flow over nicely to your ERP system, then your finance system of records, I mean, that's gold. That's solid gold. If you can get to that point, then your battle is lessened in terms of getting the right replacement prioritization strategy. So now, of course, it's not all just about the finance side. We care in maintenance. We care about the asset condition and performance. EAM has built-in tools that allow you to baseline and benchmark the individual equipment or fleets of equipment to their, the prescribed NTD measures. And this information is then used to inform your state of good repair, your MAP 21 strategy and reporting requirements, all centered around the expected useful life, which gives you, actual information in terms of how you want to manage the risk, because that's what it's all about. I mean, we can have an asset, you can drive an asset longer than expected, as long as you have the infrastructure to support it and you have the spare parts and all those things that go along with it. But if you don't have any of that, then your choices are limited. So having that information available to you in one system and across one platform is key to being able to make the right type of decision regarding life cycle condition and performance. All right, so what I have here is a diagram indicating sort of what we have on the left and what we have on the right. On the left, we have our typical traditional ERP systems where you have your workforce management, your contract management, procurement, accounting, material management, et cetera. And on the right, you have your typical EAM systems, which are managing your asset performance, your root cause failure analysis, warranty management, incident management, service requests, and the actual asset registry. This area in between is what I consider a gap. And sometimes this gap can be large, and sometimes this gap can be rather small. It really depends on how many systems you have in place that need this information. But in the end, the issue is that you have all this information in disparate systems that really should be talking to each other. So that leads us to a holistic approach of asset lifecycle information management. This is a world where these systems can talk to each other, exchange information, and you end up with one system of the truth as opposed to different, variations of that truth that can be interpreted to detrimental effects. So with respect to asset lifecycle information management, what are we talking about specifically? So I've put together here sort of some of the things that, would typically go into this system. You would have your as-built drawings, your bill of materials, illustrated parts catalogs, repair and maintenance manuals, part history books, all your engineering modifications, training manuals, and, nowadays, more importantly, software and firmware versions. It's no longer do we live in a world where you can just interchange boards just because they look and feel the same and they actually fit. We have to consider the implications of whether software versions and firmware versions are interchangeable, and whether you can, version A can be substituted for version B and interchangeably. Those are very mission critical decisions that if the maintenance side is not educated or aware of, if your system allows it, then they could potentially create a hazardous condition, not to mention, a turnback, because ultimately the asset fails. All right, so moving along here. Now, why does this matter? That's, one of the key questions that I get all the time, in terms of configuration, change management, which is really the building blocks of any EAM program. And the reason it matters is because maintainers do not have direct linkage between the maintenance system of record and the engineering baseline design data. What does that mean? Your typical project workflow is that, you have a final design review that's approved by the project team, and then there's probably a 2 to 3 year warranty phase where the vendor is maintaining that asset. Well, the vendor is doing configuration and change management in whatever system they have, not necessarily yours. So potentially you could be losing a lot of data that will ultimately play a key role in how reliable that component or asset is over time. So having that, enforcing the issue that all the information be maintained in one system of record. I can't stress that enough. Moving on to the second point, little configuration management for as-designed data. Inventory is not being mapped to their engineering baseline information, which leads to stocking the wrong parts, not stocking the critical parts, improper obsolescence management, you name it. The lack of a comprehensive unified parts catalog, a weak audit trail or normalization of failure data, or resulting engineering changes due to failure. So at that point, now we're getting into managing, in a reactive mode instead of doing it in a proactive mode. And one of the things that's often overlooked is, a lot of these information lives in native format. And, you always want to retain that native format, whether that be a CAD drawing, a 3D CAD, LiDAR, whatever that case may be. You don't want to have to be managing PDFs and, TIFF files if you can avoid it. So moving on now to, what this looks like in an actual application and how these systems could potentially exchange information. So what we have here is an example of a battery slip slide stop switch engineering modification on a type of locomotive. On the left here, what we've done is that we imported the EAM asset breakdown structure right out of EAM, and any changes that are made in EAM are promulgated down to this application. But what's important here to note on the right is that here we have a list of configurable items that we've checked into the scope of this project. So the project is a simple, configuration change of a battery slide switch that keeps failing. Here's all the technical data and information that we're checking into this project. This may have impact to illustrated parts catalogs, may have impact to bill of materials, to stocking levels, all these sorts of things. And this system ensures that we flush all those issues out so that in the end we have one centralized approach to this change, and being tied back to EAM and EAM managing the work orders associated with this change. Now we have full traceability in terms of who did the work, by when, what's the warranty terms, all that necessary information that allows it to integrate rather well. In addition to that, on our next slide here, we're looking at one of the key factors in selecting one of these systems. You want a system that is able to render the metadata in its native format. So here we're looking at a CAD file that's rendered within the application where the user doesn't need to have a CAD license in order to be able to see it. So 3 different engineers working from 3 different sites, or even external engineers, from a consultant firm, can check out this image, this CAD drawing, make some marks to it, mark it up as they wish, check it back into the project, and then the workflow owner, which would typically be like your resident engineer or your configuration manager, would then decide which changes to accept and which ones to potentially reject. What's important there is that the changes that are being rejected, sometimes that's valuable information, and it's important to retain that information. So the system is tracking all this and keeping traceability to who submitted what, when, and what was accepted and denied, and by whom, which are all critical questions. Here on this next slide, we're looking at a sample email notification that went out that, let's say this went to the configuration manager indicating that they have an item that they need to review, and here is a preview of that change. And from here, you can quickly hyperlink over to the system and start to engage in that workflow, or they could simply approve that directly from the email if you have so selected that capability in the system. So these were all critical components that we needed to make sure the system had in order to maximize our workflow and use of the application. Now, with respect to the concept of integration, it's rather basic. We're not using anything fancy in this case. You have 2 different systems. You have ALIM on the left, EAM on the right, and all the different items that they configure, own, and maintain. And then we have a file exchange protocol, which is sending information over from one system to the other. because both systems are using the same asset breakdown structure, exchanging information is relatively easy through simple flat files, or if you wanted to be more complex and set up more complex APIs, you can certainly do that. We chose to go the tried and true method of an FTP file exchange, where one system is transferring data over to the other one checks that information in and processes those changes, and then sends back confirmation message to the other system saying, hey, I've taken the changes you submitted, processed them, there are no errors. So relatively straightforward, but again, this could be more complex depending on your specific needs of the organization. So this dovetails nicely into, what good looks like. We've covered sort of like what the setup looks like, the type of information that would go into these systems, how they would function and collaborate amongst each other. And now it's just a matter of sort of identifying, we have at the bottom here, we have our cross-platform corporate systems of record for all the different systems. And although we only covered, bringing in EAM data, and with ALIM, you could also bring in, if you don't have these integrations in place, you could bring in ERP information. You can bring in other additional CAD information. The idea here is that all this information is being checked into a system, which is covered there in the middle slide, where there is work in progress and work is taking place, and we can quickly determine where we are with any given project. The master data is protected, and through configuration control measures is being updated, but only as a product of a workflow. You can't directly go in and change that information. So this data exchange is happening in at or near real time, but most importantly, it's a controlled flow of information from one system to the other. What this allows us to do is, it allows us to provide for our stakeholders, which are covered on the top rung there, the different needs of the business. So while the plant manager might have a different perspective and focused on equipment and asset performance, the engineer might be just solely focused on the different changes that are in his scope of work to execute on. So it allows everyone nicely to have this comprehensive solution that satisfies all stakeholder needs across the organization. That's really what we're trying to get to in this approach. So now this brings me to my favorite slide of any presentation, whether live or remote. It's the questions, comments, suggestions. What are you seeing out there that that might have jogged your memory based on what we talked about today? And is there anything that you'd like to discuss and cover? Happy to do it. You can connect with us through all the various means that Mike will now cover.
Hi, it's Meg here from Trapeze. I'm going to read you out the Q&As today. The first question we've got is, how did Keolis manage cultural change when they deployed the Trapeze and other ALIM systems?
Okay. Hi, Meg. Good question. I get this quite a bit. Change management is not a it's not a simple task, and it's not a one size fits all. I think the key concepts that all change management efforts must incorporate are communication. So what do I mean by that? I mean marketing, inside sales. We have our internal Feed Trapeze program where we have all these posters listed near all the kiosks and all the different depots. Where we remind the people that matter most in this process, which are the end users, that we care about the information that they're providing to us, and that it's our motto is, if it didn't happen in Trapeze, it never happened, and we take that to heart. And all that really means is that we value all the information equally, and we appreciate their efforts. Another important factor, I would say, is to engage and solicit feedback. A lot of times these efforts are sort of spearheaded by one individual, and it's pushed down through the ranks. Well, I can tell you from experience that that's not always the most effective approach. Engaging the stakeholders early and the end users early, more importantly, goes a long way into avoiding, pitfalls and bad assumptions, and sort of gives them ownership of the process. So that's important. Like I said, we have the marketing program. We also have a feedback form that any user can go into on a kiosk and send us information about bad data. We care about bad data, and we want to fix it. So we have what we call a Trapeze data integrity form. It's a web form that a user can go in. They can suggest new task codes for us, new part associations. Naming is a big deal. We may know it as an actuator, but they know it as a lever. And to them, that makes all the difference in the world when they're doing keyword searches, things of that nature. Obsolete parts, a lot of times it's the technician that, determines that that a part is no longer applicable. And maybe that got left out of the change control process. So we have an undocumented part being installed on an equipment. So we give the technicians an opportunity to submit things to us that they see as anomalies, and it allows us to improve the system going forward.
Thanks for that, Eva. I can see your feature piece sign in the background, which is such a great initiative. The next question we've got is, how important is it for Keolis business systems to be able to interface with each other? Can you give us some examples of interfaces that Keolis Boston has developed?
Yes, well, integrations are tricky but necessary. I'm a proponent of having as much built out in one application as possible, but obviously that's not realistic in a large operation. So we have a lot of legacy systems for ERP and finance, such as Great Plains, that we needed to integrate with EAM inventory management. So, that happened about 3 years ago now, and it's been critical in improving our inventory management capabilities. There's another integration that we have with our train dispatch system, where delays are reported by the engineers and conductors. So we get that delay information back into EAM, which kicks off the incident investigation process that ultimately gets resolved on a work order where a technician declares a part or component the root cause of that reported symptom. And that's critical to have because it really informs your performance management and maintenance management regimes. I think the integrations are, sometimes can be very complicated and hard to maintain, but it's important that you're capturing those critical data elements amongst the different systems so that regardless of which way you're looking at it, you have the full picture, if you will.
Great, thanks, Eva. Another question. Can you give an example of a business process that was improved through the implementation of an ALIM solution?
Yeah, so the first one that comes to mind with respect to a business process that was drastically improved was just document control. Up to this point, really, document control was a relative term, depending on the business that was performing it. And essentially, it was all being maintained in flat files. You never really had an idea if you had the latest and greatest, the version of that drawing. So, that was having that document control along with a robust change control workflow allows us to have confidence in that when we look at a drawing that is in fact the latest and greatest version of that drawing. And then along with that would be configuration management and control, which obviously having a standardized system with built-in configurable workflows allows you to then route things for review and approval, allowing for all the different stakeholders to sort of weigh in with their comments and being able to archive those comments, because sometimes even though something is implemented doesn't mean that there weren't leading indicators to what was wrong or what someone else thought. So capturing all that information is critical so that you have it in a future state.
Great, thanks, Eva. Final question that we have time for today. What value did Keolis get from the Trapeze system in supporting EAM and ALM processes, and how?
Okay, well, that's, I spent a lot of time in the presentation on slide 10 talking about that. Those are the concrete, tangible things that having a system like ALM and EAM together help to inform. But just to, to cover that again, it's, one of the key things that we care about here is the audit trail, and having these systems integrated allows us to have a strong audit trail. Also, you have your direct link to the engineering core documents, which is sometimes troublesome when you're trying to start a project. You don't have all the engineering drawings that you need. So a lot of times things have to be, reverse engineered, when in reality, someone else has those files that you just don't know they have them. So having traceability, accountability, and trackability of the information is key. And I'd say the other big improvement gains from an effort like this would be your improved inventory and configuration management processes, along with your revision and version control, which plague a lot of properties that are using legacy systems such as Excel and folders with Internet Explorer folders with controls and permissions and that sort of thing. Having this all in a centralized system, I can't understate how much that actually helps the people on the shop floor, getting them the access to the right information when they need it, and not having to wait around. That supports a lot of and promotes a lot of best practice downstream effects.
Great, thanks, Eva. That's all the time we have for questions today. Any questions we didn't get time to answer during the webinar, Eva and Michael will reach out. And please do feel free to reach out to Michael or Eva directly if you do think of anything further. I just remind everyone that we do have some resources available today if you'd like to find out more about how the Trapeze EAM system works. If not, thank you for being here today, Eva, and thank you, Michael, for hosting.
Thank you for having me.